Now this question says solve for x and y. There is an equation given 2 raised to the power x plus 3 raised to the power y is equal to 5. And x and y are natural numbers, right? Okay. So here if you look at this closely, natural numbers mean the minimum value of x and y has to be 1. So x and y both have to be greater than 1, greater than equal to 1. Now this is a very easy situation because the minimum we have to take x equal to 1. So if I put x equal to 1, I'm saying if we put, why I'm saying that because 5 is a very small number, there will not be many possibilities. So if you put x equal to 1, what will happen? If you put x equal to 1, it will become, the equation will become 2 raised to 1 plus 3 raised to y equal to 5. Now 2 raised to 1 is 2, so 3 raised to the power y will be 5 minus 2, which is 3, which is 3 raised to 1. That means y is also equal to 1. So one solution that we get is x equal to 1 and y equal to 1, right? Now what if I put, if we put x equal to 2, what happens then? If we put x equal to 2, then you can see that it will be 2 square plus 3 raised to y equal to 5. Now 2 square is 4, so 4 plus 3 raised to y equal to 5. That means 3 raised to the power y is equal to 5 minus 4, which is 1. Now 1 as a power of 3 can be written as 3 raised to 0. That means y equal to 0. Now 0 is not a natural number, so we will not take it, right? Further, if we want to put x equal to 3, then 2 cube will become 8, which will be more than 5. So anyways, we are not going to get any natural number value after that. So there is only one solution that is possible, x equal to 1 and y equal to 1. Please understand that this question will be asked only for a small value like 5. Okay, for larger values, we will have many possibilities. So we need one more equation. Now this question was meant to be solved like this only because the values are small. You can directly put and check which one satisfies or what value can satisfy. Right? So the answer of this question is x is equal to 1 and y is equal to 1. Okay, now let's take another question. Now this question, you see that there are two variables x and y. The values are large, very large, and two equations. So what we need to do, there are multiple methods. So let me put as like this. If I say method 1 for this question, what do we do in this? Let's assume that 4 raised to the power x is equal to a and 5 raised to the power y is equal to b. Right? So that means the first equation, let me say like this, first equation can be written like this: 4 raised to the power x plus 5 raised to the power y is equal to 69. This gives us a plus b is equal to 69. Right? Similarly, the second equation, let's say this is the second equation. Now the second equation can be written as, it is 4 raised to the power x minus 1 plus 5 raised to the power y plus 2. That is equal to 141. Now here, 4 raised to x minus 1 can be written as 4 to the power x divided by 4 to the power 1 plus 5 raised to the power y plus 2 can be written as 5 raised to the power y into 5 raised to the power 2 is equal to 141. Now 4 raised to x is a, 5 raised to y is b. So this equation can be written as a by 4 plus 25b, 5 square is 25 and 5 raised to y is b. This is equal to 141. So if you multiply by 4, it will give us a plus 100b is equal to 141 into 4 is 564, right? So these are the two equations, a plus b equal to 69 and a plus 100b equal to 564. This is how, these are the two equations that we need to solve to get values of a and b first. Okay, so I write the equations again. I write the second equation first. A plus 100b is equal to 564 and the second equation is and the first equation is a plus b equal to 69. Let's do the simple subtraction. A minus b minus 69 minus. So a gets cancelled. 100b minus b is 99b. And 564 minus 69 is 495. Right? And you can clearly see that b will be equal to 495 divided by 99. That gives us 5. Right? So we have b equal to 5. If you put b equal to 5 in this first equation, that is a plus b equal to 69, you will get a equal to 69 minus 5. That means a is equal to 64. But remember, b was 5 raised to y and a was 4 raised to x. So what we need to do is we come back here and we say that b is equal to 5 is equal to 5 raised to y. Now 5 is 5 raised to 1. So we have y equal to 1. Similarly, a, which is equal to 64 in this case, is equal to 4 raised to x, and 64 is actually equal to 4 cube. That means x is equal to 3. Right? So our final answer of the question will be x equal to 3 and y equal to 1. Right? Now this is one method of solving the question where we have used both the equations. We have created linear equation from here. Okay, and we have tried to solve this question, right? Now the other way does not require solving the equations. Let me take another method for this. Now we'll talk about method 2. Okay. In method 2, we will not use both the equations. We'll use only one of the equations. Let's see how. 4 raised to x plus 5 raised to y equal to 69. Now in this equation, see, we know the powers of 4. Let me put it this. 4 raised to 0 is equal to 1. 4 raised to 1 is equal to 4. 4 raised to 2 is equal to 16. 4 raised to 3 is equal to 64. 4 raised to 4 is equal to 256. Now if you look at this here, it is 69 is the maximum value. So 4 raised to x has to be lesser than 69. That means 256 will not be useful for this equation. But here the value of 4 raised to x can be any one of these things. That is 1, 4, 16 and 64. Let's put one by one. If I put 4 raised to x as 1 plus 5 raised to y equal to 69. From here we will get 5 raised to y as 69 minus 1, that is 68. Now 68 is not a power of 5, so we will not get a suitable value of y here. Right? What we are doing is we are putting the values of 4 raised to x from here. Okay. Now let's take the next one. If I take 4 raised to x as 4 plus 5 raised to y, that is equal to 69. Now this means 5 raised to y from here will be 69 minus 4, that is 65. Now 65 is not a direct power of 5, so this also is not useful. So 1 is not useful, 4 is not useful. Now let's take 16. So if I take 16 plus 5 raised to the power y, this is equal to 69. This will give us 5 raised to the power y equal to 69 minus 16, that is 53. Oh, this also is not giving us any suitable value for y. Okay. Now let's say if I put 64 in place of 4 raised to x, if I put 64, what will happen? So 64 plus 5 raised to y, that is equal to 69. This gives us very clearly that 5 raised to y is equal to 69 minus 64, which is 5 raised to 1. That means y is equal to 1. Right? And this was 4 cubed, so x is equal to 3. So please understand that only one equation was sufficient to answer this question. Okay. Now you also need to check the second equation whether it is satisfied by these values or not. If I put x equal to 3 here, put x equal to 3 in this and y equal to 1 in this, what will happen? Let's see. It will become x raised to 4 raised to 3 minus 1. So that gives us 4 square. And 5 raised to 1 plus 2, that is 5 raised to 3. Now 4 square is 16, 5 raised to 3 is 125, that is equal to 141. Right? So that means these values of x and y also satisfy the second equation. Hence, that is the correct answer. Right? So you could have also used the second equation for this. Let me put it this way. If I use only the second equation, then what happens? I'll write the second equation here, 4 raised to x minus 1 plus 5 raised to y plus 2, that is equal to 141. Okay. Now here I'll use the powers of 5. Let's see how it works. 5 raised to 0 is 1. 5 raised to 1 is 5. 5 raised to 2 is 25. 5 raised to 3 is 125. 5 raised to 4 is 625. Now please see that the addition here is 141. So 625 is higher than 141, so it won't be useful in any case. Now let's put the values of 5 raised to y plus 2 as 1, 5, 25 and 125 one by one and check the values of the other part, how it comes. If I put 4 raised to x minus 1 plus, in place of 5 raised to y plus 2, if I take 1 equal to 141. So from here, we'll get 4 raised to x minus 1 as 141 minus 1, which is 140. Now 140 is not a power of 4. So this is wrong. So 1 is wrong. Okay. Now let's take the second case. 4 raised to x minus 1 plus 5. If that is 141, then what will happen? From here you can see that 4 raised to x minus 1 is 141 minus 5, that is 136. Even 136 is also not a power of 4. So this 5 is also not correct. Now let's take the next one, 4 raised to x minus 1 plus 25, that is equal to 141. Now what will happen? From here we get 4 raised to x minus 1 is equal to 141 minus 25, that is 116. Now 116 is not a power of 4, so this is also wrong. So 25 is also wrong. Right? Next option, that is 4 raised to x minus 1 plus 125 equal to 141. Now this will give us 4 raised to x minus 1 equal to 141 minus 125, that will be 16. Now 16 is 4 square, right? So x minus 1 is equal to 2, so x is equal to 3, right? And we have taken 5 raised to 3 as 125 here, and here the power of 5 was given as 5 raised to the power y plus 2. That means y plus 2 is equal to 3. So this gives us y equal to 1. So we are going to get the same answer in any case. Alright. But this would be a little faster and better as compared to solving the equations. Okay. Now let's go to the next question. Now this again is a very beautiful question. It says find x, 3 raised to the power x plus 3 minus 3 raised to the power x minus 3 equal to 6552. Again there will be multiple methods. So I'll take first method 1. Look at this carefully. Method 1 is based on direct values. Let's see. One thing is very clear. This value is larger. This value is smaller. Also both of these are powers of 3 and the difference is 6552. That means the first number has to be more than 6552. Let me help you to recall the values of powers of 3. 3 raised to 0 is 1. 3 raised to 1 is 3. 3 raised to 2 is 9. 3 raised to 3 is 27. 3 raised to 4 is 81. 3 raised to 5 is 243. Right? 3 raised to 6 is 729. 3 raised to 7 is 2187. 3 raised to 8 is 6561. 3 raised to 9 is 19683 and so on. Now here we are saying that this first value has to be more than 6552 and has to be a power of 3. Here if you see, the first value that is more than 6552 in this case is 6561. Oh, so let's do one thing. Let's, in place of 3 raised to x plus 3, put 6561. Let's check what happens. So if I take 6561 minus 3 raised to the power x minus 3 equal to 6552. So what we are saying here is, we are taking 3 raised to the power x plus 3 as 6561. Right? Now from here, what we get? 3 raised to x plus 3 equal to, we know that 6561 is 3 raised to 8. So we get x plus 3 equal to 8. That is x equal to 5. Now we don't know whether it is correct or not. That will be confirmed from here. How? Let's see. Bring 6552 to this side. So it becomes 6561 minus 6552. That is equal to 3 raised to the power x minus 3. Now 6561 minus 6552 is 9. Subtract normally. That is 3 raised to the power x minus 3. Now 9 is 3 square. So 3 square is equal to 3 to the power x minus 3. So 2 is equal to x minus 3. From here also you get x equal to 5. Right. That means this x equal to 5 is a correct answer. Oh, so 6561, our assumption that we started with is correct. Right. So this is one good way of doing the question, if at all you remember this. See, if you don't remember this, then in the exam doing this whole thing will consume a lot of time. So then it won't be useful. This method is useful only if you directly memorize that above 6552, there is a power of 3, that is 6561, which is definitely difficult. Hence, the second method. Let's look at the second method now. Now, in the second method, what we do, we follow the normal procedure. Normal procedure as in 3 raised to the power x plus 3 can be written as 3 raised to the power x into 3 raised to the power 3 minus 3 raised to the power x minus 3 can be written as 3 raised to x divided by 3 raised to the power 3 is equal to 6552. Let's take 3 to the power x common. 3 cube is 27 minus 1 by 3 cube is 1 by 27. That is equal to 6552. So from here we get 3 raised to the power x into, in denominator 27, in numerator 27 into 27, that is 729 minus 1, that is equal to 6552. Alright. Now this gives us 3 to the power x into 728 divided by 27 is equal to 6552. If you look at this closely, 8 9s is 72. So in fact 728 cancels 6552 9 times. So we have 3 raised to the power x is equal to 27 into 9. Now 27 is actually 3 cube, 9 is 3 square, right? So the powers on the right hand side get added. We have 3 raised to x is equal to 3 raised to 3 plus 2, which is 3 raised to 5. So this tells us very clearly that the value of x is equal to 5. So this was one conventional method, not very difficult method. This is also useful. Alright. I am so sorry. This was question number 9 actually. Okay. Now let's take up one more question. This question says 5 to the power x plus 3 minus 5 to the power x minus 3 is equal to 78120. Now this is a very interesting question. Here also you can use the powers of 5. That will be really difficult to do. Okay. But let me give you all the methods. So first method 1. Okay, if I give you the method 1, as I said, the values based method, that is 5 raised to 0 is equal to 1, 5 raised to 1 is equal to 5, 5 raised to 2 is equal to 25, 5 raised to the power 3 is equal to 125, 5 raised to the power 4 is equal to 625, 5 raised to the power 5 is equal to 3125, okay, 5 raised to the power 6 is 15625. Okay, 5 raised to the power 7 is 78125. Right. You know, just by looking at the 78125, it should strike that 78120 is slightly below 78125. Now here, something minus something, we are getting 78120. That means the first value has to be more than 78120, and also it is a power of 5. So what we will do, we will assume it to be 78125. So let's assume that this is 78125 minus 5 raised to the power x minus 3 equal to 78120. So what we are saying, that we are assuming 5 raised to the power x plus 3 equal to 78125. That means we are assuming 5 raised to the power x plus 3 to be 5 raised to the power 7. So this gives us x plus 3 equal to 7, that is x equal to 4. Right? Let's check from the second part whether it is correct or not. Okay. Now from this equation, bring the 78120 to this side. This will become 78125 minus 78120, that is equal to 5 raised to the power x minus 3. Now 78125 minus 78120 is actually 5. That is 5 raised to the power x minus 3. Now 5 is 5 raised to 1. So 1 is equal to x minus 3. Right, so that means x equal to 4. So from both the places we are getting x equal to 4 only. Hence this is the correct answer. Right? Again, not very difficult to understand, but you have to memorize the values to be able to use this. Okay. Now let's take second method for the same question. Now we take up method 2 for the same question. Let's see how it goes. The normal conventional process, separate them. So 5 raised to the power x into 5 raised to the power 3, because the power is x plus 3. Second one, 5 raised to x minus 3. It can be written as 5 raised to the power x divided by 5 raised to the power 3 equal to 78120. Right? If you take 5 raised to the power x common, you will have 5 raised to 3, that is 125, minus 5 raised to x has gone out. So 1 upon 5 cube, that is 125, equal to 78120. So this gives us 5 raised to the power x. LCM is 125. In numerator, we'll have 125 into 125, that is 125 square, that is 15625, minus 1 equal to 78120. So this gives us 5 raised to the power x into 15624 divided by 125 equal to 78120. Now look at this closely. 5 4s is 20, 15 5s is 75. In fact, 15 6 24 cancels 78120 5 times straight away. So from here we have 5 raised to the power x is equal to 125 into 5. Now 125 is actually 5 cube. 5 itself is 5 raised to 1, so which is 5 raised to the power 3 plus 1, that is 4. So 5 raised to x is equal to 5 raised to 4. So this tells us very clearly that x is equal to 4. So this was the other way, the conventional way of doing this. But even in this, you have to utilize this calculation of 15625. Okay. So in any case, calculation has to be done. See, wherever it is necessary, you have to do that calculation. Okay. Now, in this particular question, only in this particular situation, there is another thing that I should point out. Let's see. I'll say it is method 3 for the same question. Alright. Now, in this method, there is a very beautiful information that is used. If you remember the powers of 5, 5 raised to 0 is 1, 5 raised to 1 is 5. But after this, all the powers have 25 in the end. 5 square, 5 cube, they all have 25 in the end. Right? I'll just write a couple of them. So all of them will have 25 for sure. Now here, x plus 3 is a very large number as compared to x minus 3. That means 5 raised to x plus 3 will definitely be more than 5 square. Right? So this value definitely ends in 25. Now, if this value also had ended in 25, then after subtracting, we must have got 0, 0 in the end, which we have not. We have 20 in the end. What does it mean? It means 5 raised to x minus 3 cannot have 25 in the end. Now, if 5 raised to x minus 3 cannot have 25 in the end, then there are only two possibilities. It will be either 5 or 1. It will be either 5 raised to 1 or 5 raised to 0. There is no other possibility. Alright? I'll repeat in a different manner. We are saying that this 5 raised to the power x plus 3 is definitely going to have 25 in the end because it is a large power. Right? But 5 raised to x minus 3 has to be such a in such a number that after subtracting, we should get 78120. That means we should get 20 here. So by looking at this, you can be sure that in place of the second number, we will have something that has 5 in it. Only 5 in it. Then only after subtraction, we will have 20. We cannot take 1 because 25 minus 1 will be 24. Here it is 20. So we must take the second number as 5. So from here only we can say for sure that 5 raised to x minus 3 has to be 5, which is 5 raised to 1. Okay, so x minus 3 is equal to 1, that is x equal to 4. But please understand that this was a very specific step only for this particular situation because of this 20. Okay, so we don't have to get into these detailed values of 5 raised to x plus 3. Whatever it is, it will always have 25 in the end. Second number should be such that after subtraction we should get 20 here. The only one possibility for the second number is that it has to be simply 5. That's it. So the answer of this question is x equal to 4. Alright. So this is where we have completed a good number of questions related to indices.